So this is the specimen paper for the AS Pure Maths paper, and in my filing it's paper 5. So we'll look at each question in turn. So you can pause the video on the question alone. If you let the video run, you will then have a hint for each question. So if you're not sure how to engage with the question, play the hint and pause at that point. And then thirdly, the video will then run for each question onto a complete solution. So starting off with question 1. So pause the video now if you just want to have a go just from the question. Now your hint. So to dy dx is obviously when we differentiate, and we're going to differentiate each term in turn. So there's 4 pieces to differentiate. Remember how we differentiate. Step 1, you multiply by the current power, and then step 2, you reduce the power by 1. Now for part B, the range of values of x for which y is increasing, this is when dy dx is greater than 0. It's greater than 0. So take your answer from part A and solve it being greater than 0. And do note that you've got to give your answer in set notation. So set notation looks like this, with the union in the middle. So the solution for question 1, when we differentiate, so we're multiplying by the current power, reducing the power by 1 for each of the 4 terms. So 2x cubed becomes 6x squared, minus 2x squared becomes minus 4x, and minus 2x becomes minus 2, and the plus 8 disappears. Now, it's an increasing function when dy dx is greater than 0. So taking our answer from part A, we're setting it to being greater than 0. So as each term is even, I've just chosen to divide by 2 just to make it a little bit easier. Now, it may be that you can factorize by inspection and just jump straight to this final line here. If you can't, then you can do this long-winded way. So we're looking for 2 magic numbers that multiply to be the 3 multiplied by the minus 1, which is minus 3, yet at the same time they add to be the coefficient of x, which is the minus 2. Now which 2 numbers do this? That's 1 and minus 3, because 1 times minus 3 is minus 3, and 1 added to minus 3 is minus 2. So our first step is to split this middle term, this minus 2x, into 1x and minus 3x. Doesn't matter which way round, I've popped the minus 3x first. So we've gone from 3 terms to 4 terms. Okay, the next line is we fully factorize the first 2 terms, and then we fully factorize terms 3 and 4, which is what I've done here. So 3x squared minus 3x becomes 3x multiplied by x minus 1, and 1x minus 1 is just one lot of x minus 1. And you will see that we have this repeated bracket. Then our final pair of brackets are the 2 components which aren't in a bracket, so the 3x and the plus 1, and then the repeated bracket. So our 2 solutions are going to be what makes this first bracket 0 and the second bracket 0. That's minus a third and plus 1. Now, to help me gather my thoughts on the inequality, I've just drawn a little sketch to help me. So our solutions are at a minus a third and plus 1. This is a positive quadratic. 6x squared is positive, so it's going to be a positive parabola. Now, the solutions where it's greater than 0 are all the set of points above the x-axis. So it's these 2 sets of points that I've done here in I've marked in orange. So if you were writing that normal inequality format, it would be where x is greater than 1 and x is less than minus a third. Although I wouldn't have written it like this, I would have written it as 2 separate sets of points. So my final answer, if it had not been asking for set notation, would have been x is less than minus a third and x is greater than 1. So I would never have written it like this. Okay, now putting it into set notation, you've just got to learn how you set this out. All right, so open curly bracket, x colon, we want the set of points where x is less than minus a third, close the squiggly brackets, union, squiggly bracket, x colon, x is greater than 1, squiggly bracket. Question 2, so pause the video now if you want to just have a go with no hint. Now, the hint for question 2, I think whenever you have a vector question like this, just draw a little sketch to help you gather your thoughts. Now, we're having to go from A to B, so we really need to have a look at the two vectors from O to A and O to B. So just a quick sketch to help us gather our thoughts. So remember, 4i plus 2j means 4 to the right and 2 up, or in column format, 4, 2. So just a little sketch to sort of represent that. So from going from O to O would be 4 along and 2 up, and going from O to B would be 6 to the right and 3 down, or 6 minus 3 in column format. So O to B, 6 to the right and 3 down. Now going from A to B, how do I get from A to B? Well, I go A to O and then O to B. So see if you can figure out what the answer is going to be from that. Now for part B, if we've got to show that the quadrilateral OABC is a trapezium, you're going to need to show that two sides are parallel, but not the same vector. You know, we're not trying to show that it's a rectangle. So 2 are parallel, okay, and 2 aren't parallel. So the key bit for part B, can we go and show that two sides are parallel? Now, in vector format, how do you know if they are parallel? Well, they are two parallel vectors are going to be multiples of the same vector. So one might be double the other, or one might be triple the other, or something like that. So have a think about that. So pause now if you want to have a go with the hints. So our solution for question 2. So we discussed in the hint of drawing a sketch. Now, going from A to B, we're going to go A to O, which is going down this vector the wrong way. So that's minus 4, minus 2. And then O to B was our 6, minus 3. Adding the vectors together, minus 4 at 6 is 2. And minus 2 minus 3 is minus 5. Now, you could give your answer in column format, but given our question was in IJ format, I've given it as 2i minus 5j. Now I've done for part B, I've done a quick sketch just to help me gather my thoughts, and whilst it's only a sketch, I can see that my two parallel sides of any are going to be AB and OC. Those are the potential two parallel sides. Now I know the vector AB from part A is 2 minus 5, and the vector OC I'm given in the question is 8 minus 20. Now I can see that OC is just 4 times the size of AB. So it is parallel. OC is parallel to AB, but not the same length. Therefore, OABC is a trapezium. Question 3. So the hints for this question. Now the key thing here is just to pick up that there's a linear model, okay? So it's going to be following y equals mx plus c. It's just a straight line. Now it looks complicated on the face of it, but I think with a little sketch you can gather your thoughts, because at the end of the day, just think y equals mx plus c. So let's just go and sketch and draw the data that we know. So we know, so I've done time along the bottom and the volume as my y-axis. And I know after 24 minutes, the volume is 4. So that's that point there. And I know after 60 minutes, the volume is 2.8. So those are my 2 points here. And really from then onwards, I'm away. Okay, I've got a straight line through those points. I can just use y equals mx plus c to work out, and then fill in the gaps. So work out what the gradient is by doing y step over x step. So the y step is this length here from 4 to 2.8. And the x step is from 24 to 60. And be careful, we're going downhill, so it will be a negative gradient. And then substitute in then one of the points to allow you to work out what C is. Now for part B, the initial volume of water is going to be your C from part A of the answer, isn't it? It's going to be the volume when t equals 0. So it's going to be this y-intercept from part A. And then from B part 2, the time taken for the tank to empty, well, we're looking for this point down here where the volume is 0. So just substitute into your equation from part A, the volume being 0. And then for C, just have a logical think about why this might not be appropriate. So the solution for question 3. So we've got the sketch as discussed in the hint a bit earlier on. So our gradient I'm going to work out from the y step, which is from 2.8 to 4, this length here, which is 1.2, over our y step of 60 take away 24, which is 36. However, this line is going downhill left to right, so it will be a negative gradient, and 1.2 over 36 is 1 over 30. So that is my m, my gradient. Now to work out c, I've just substituted in one of the points I know. I know that when t is 24, v is 4. So substituting in x being 24 and y being 4, I can work out that c is 4.8. So I know what m is, I know what c, so there is my linear equation linking v and t. Now for part B, part 1, the initial volume of the water in the tank, well that's this point up here, okay? We've just worked that out in part A, it's C. It's the volume when T equals 0. So that's 4.8 meters cubed. And the time taken for the tank to empty, so that's this point down here where the line crosses the x-axis, is when V equals 0. So solve V being 0 to part A. So 0 equals minus a 30th t plus 4.8. So I've taken away 4.8, multiplied by 30, and by minus 30, and I get 144 minutes. Now for part C, I've just copied and pasted it from the mark scheme here. State any logical reason. The tank will leak more quickly at the start due to the greater water pressure, or the hole will probably get larger and so will start to leak more quickly. Or you could argue the opposite. The sediment could cause the leak to be plugged, so the tank would either not empty or empty more slowly. Anything like that will suffice. So have a go at question 4 on transformation of graphs. So pause now if you want to go from scratch, or continue playing the video for the hints. So for part A, okay, the 2 is outside the function, so it affects the y value and does what you would expect. So we're going to be doubling the y coordinate. So double the y coordinate for the turning point, that's the minimum on this occasion. Now for part B, state the largest root of the equation g of x plus 1. Now the roots are where the graph crosses the x-axis. So our g of x roots are at 2 and at 7. Now here we're doing g of x plus 1. Now this the transformation is the change is inside the function, so it affects the x value doing the opposite to what you would expect. So you're going to be taking away 1 from the root, but note you want the largest root, so you've got to take away 1 from the original largest root. Now for part C, state the range of values of x for which g dash x is less than or equal to 0. Well, this is when g of x is going downhill, so it's this set of points from 4 and to the left. All those points there are when the graph is going downhill. So what range of points is that? And state that as an inequality. Now, you will have no real roots if the graph does not cut the x-axis. So think about how high you would have to lift this graph up, how you would have to shift it in the y direction in order to no longer be cutting or touching the x-axis. So the solutions for question 4. So the 2 is outside the function, so we're going to be doubling the y coordinate of the minimum point. So the original minimum point was 4 minus 1.5. Double the y coordinate, get 4 minus 3 for part A. Now the original roots are at 2 and 7. For part B, we've got x plus 1 inside the function, so we're going to subtract 1 from the x coordinate. Our biggest root was 7, so subtracting 1 from that, our root is now 6. Now where g dash x is less than or equal to 0 is where the curve is decreasing. Now that's this set of values here, right down to the 4. So this is where x is less than or equal to 4. okay, because it says the range of values of where it's less than or equal to 0. So do include the less than or equal to 4 sign, because it does include the stationary point itself when the gradient is 0. Now for part D, given that the equation gk plus k, gx plus k equals 0, where k is a constant, has no roots, state the value. So we're going to be shifting the graph upwards. Okay, this is outside the function. So how far would we have to shift the graph upwards to no longer either cross or touch the x-axis? Well, we're going to have to go greater than 1.5 to get beyond the x-axis. So k has got to be greater than 1.5. Question 5. So the hint's just about to follow. So using the factor theorem to explain why f of x is divisible by x plus 3. Well, what you need to do, you need to take minus 3 and substitute that into the function and show that you get 0. So if you can show that minus 3 substituted into the function equals 0, then x plus 3 is indeed a factor. So for part B, just do that algebraic division. So take your function and divide it by x plus 3. You will find that this gives you a quadratic. So just go and factorize that quadratic as well. So you're left with 3 pairs of brackets. Now for part C, obviously we fully factorized the numerator in part B. So go and fully factorize the denominator and then cancel down the brackets, and then just make sure you give your final answer in that format. So the solution for question 5. So substituting minus 3 into the function, I get minus 27, add 27, add 12, minus 12, which is indeed 0, and therefore x plus 3 is a factor of f of x. So f of x is divisible by x plus 3. Now for part B, so carry out this long division. Okay, so you're starting off by saying x times what gives you x cubed, and that's x squared. So that was the first thing I did. So I've then said x squared times x is x cubed, and x squared times 3 is 3x squared. Now taking that away, I get 0, so I can bring down fully my minus 4x minus 12. So minus 4 times, what times x gives me minus 4x, and that is indeed minus 4. Minus 4 times x is minus 4x, minus 4 times 3 is minus 12. Taking that away, we get 0 as a remainder, which we would expect because x plus 3 is a factor. So partially factorized answer is x plus 3, x squared minus 4. Now this is the difference between two squareds, so your final answer should be your x plus 3, and your x squared minus 4 factorized is x plus 2, x minus 2. Now for part C, I need to just start off by fully factorizing this denominator. So I've taken out the x, and then I've factorized x squared plus 5x plus 6, giving me x squared, x plus 2 times x plus 3. So setting out the question in its factorized format, my numerator from part B is x plus 3, x plus 2, x minus 2. And I've just worked out the denominator factorized as x, x plus 2, x plus 3. So our x plus 3's and our x plus 2's cancel, leaving us with x minus 2 over x. So putting each of the terms of the numerator over the denominator, x divided by x is 1, and minus 2 divided by x is minus 2 over x. So I've now got it in the format as required by the question. Question 6. So pause now if you want to have a go before the hint. So here's the hint. So for part A, you've just got to find a value for n between 3 and 10, that when you substitute it into this, you don't get a prime number. Okay, so that's what we need to do for part 1. Now for part 2, we've got to do this in general terms. So remember 2n, if you double anything, you get an even number. So 2n plus 1 is an odd number. Obviously, one more than an even number is an odd number. So given that we've got to do the difference between the cube and the square of an odd number, so it's the same number, okay, as they show in the example, the same number being cubed, take away the same number being squared. So our opening line of workings is going to be an odd number cubed, take away the same odd number squared. So you've just got to process that and end up just showing that when you process that, you end up with an even number. So the solution to question 6, for part A, if you use n being 8, you get 8 squared, take away 8, take away 1, which is 55. And obviously 55 is not a prime number because 11 fives are 55. So when n is 8, the statement is false. Now for part 2, as mentioned in the hint, you've got to be clear here that we're talking about the same odd number being cubed and squared. So you don't need to go in into using n and m. You can just use n throughout. So let 2n plus 1 be any odd number. Okay, you double any number and add 1, it's going to be odd. So just following what the question is asking you to prove, the difference between the cube and the square of an odd number. So the cube of an odd number is 2n plus 1 all cubed. The square of the same odd number is 2n plus 1 all squared. So the difference between the two is obviously when you take away the smaller one from the bigger one. So all I've done then, I've just worked out what 2n plus 1 all squared is, and I've just done that at the top. Then I've worked out what 2n plus 1 all cubed is, which is this here. So the difference between the two is this, it being cubed, take away this, it being squared. Now just be careful when you process the second part of that. That's minus 4n squared minus 4n minus 1. You've got to attach that minus 1 to each of the three terms. You'll then see that the plus 1 and the minus 1 cancel out. Excuse me. In gathering up your squareds, you see that you get 8n cubed plus 8n squared plus 2n. Now I've got to prove this is always even. So if I just factorize and take a 2 out, I get 2 lots of this, what's in the bracket. And by definition, if I'm doubling something, it is therefore by definition even. Question 7. So pause the video now if you want to have a go before you see the hint. So the hint for this. So for part A, we've got to expand this all squared. So obviously it's the bracket times itself. So just process that doing the for clause. Now for part B, we've got to use the binomial expansion. Now we're given the formula in the formula book that I just popped up here. So for this particular one, our A is going to be 1. Our b is going to be 3/4 of x, and our n is going to be 6. So just substitute that into the formula for the first 4 terms. Now for part C, hence find the coefficient of x in this expansion. So this first part of part C is obviously the expansion we got from part A, and the second part of part C is the expansion we got from B. So I've popped these down here. Now you've got to consider when you multiply these out, which clause give us some x squared? No, some x's, sorry, not x squared, some x's. We've got to find the coefficient of x. Now obviously 1 times the 9x over 2 gives us some x's. That's my red claw. Similarly, the 6 over x times the x squared term, the purple claw will give you some x's. And thirdly, the 9 over x squared times the x cubed term, my green claw, will give you some x's as well. So you've got to process those 3 claws and see what your coefficient of x is when you add those 3 together. Into question 7. So for part A, expanding the bracket with the bracket times itself. So that's obviously 1 plus 3 over x times 1 plus 3 over x. Do the for clause, then gather up the like terms, the 2 terms in the middle. So that bit there in blue. Now for part B, use the binomial expansion to find in ascending powers of x the first 4 terms in the expansion. So as I said in the hint, using the formula in the formula booklet, we've got A being 1, B being 3x over 4, which is the same thing as 3/4 x, and n being 6, and just substitute in for the first 4 terms, which I've done here, the first term, second term, third term, fourth term, then multiply out and simplify to get this answer here in green. Now for part C, find the coefficient of x. So you've got to consider where do your x's crop up when the first component is multiplied by the second component. Now the first component is our answer from part A, and our second component is our answer from part B. So I've just popped those two next to each other here. Now where do we get x's? Well, it's when we've got the red claw, the purple claw, and the green claw. So doing those three expansions here, we've got the red claw, the purple claw, and the green claw. Then simplify those. We get these coefficients of x. Okay, adding those three together, this is our final answer. Question 8. So here's the hint. So the integral from a to 1 to a of root 8 x, so the square root of 8x, we can break the root 8x down to being root 8 multiplied by root x. Now root 8 is a constant, so that can be taken outside the integral. So we've got root 8 times the integral. Now we know what the area under the graph is from 1 to a of root x is 10. So we've got 10 lots of root 8, which you then just need to simplify. Now for a part 2, bear in mind that the area under of the graph from 0 to a comprises the area under the graph from 0 to 1 and from 1 to a. Now we know that the area under the graph from 1 to a is 10, so we've just got to work out the area under the graph from 0 to 1. So you need to integrate root x. Now remember, root x is x to the power of a half. So to integrate that, add 1 to the power and divide by the new power, and then your boundaries are going to be between 0 and 1. And then, so once you've got that area under the graph, add it on to your r, which is 10, to get your total area under the graph. Now for part B, you just need to go and set the integral from 1 to a of root x to being 10. We know that the area between 1 and a is 10, so just similar to a part 2, the integral of root x, which is x to the half, add 1 to the power, divide by the new power, and then substitute in a, substitute in 1. When you take one away from the other, you've got it equal 10. And the solution to question 8. So for part 1, root 8 over x can be broken down to being root 8 root x. Root 8 is a constant, so that can be taken outside the integral. So it's root 8 multiplied by the area under the graph between a and 1, which we know to be 10. So that's root 8 times 10, which is obviously 10 root 8. The question asks for it in its simplest form. Now root 8 is 2 root 2. 10 lots of 2 root 2 is 20 lots of root 2. Now for part 2, the area under the graph between 0 and 1 is the area between 0 and 1 added together with the area between 1 and a, which we know to be 10. So we need to integrate between 0 and 1. So to integrate root x, which is x to the half, add 1 to the power, which is 3 over 2, divide by the new power. Now when we go and substitute in 1, which gives you 2/3, substitute in 0, which gives you nothing. So the that area there is going to be 2/3. Add that to the other area of 10, gives us 32 over 3. Now for part B, we need to work out what a is. Now we know that the area under the graph between 1 and a is 10. So that's our starting position. When we integrate x to the half between 1 and a, we get 10. So integrating this, we get our add 1 to the power, divide by the new power, we get this. Substituting in a, we get 2/3 a to the 3 over 2. And substituting in 1, we get 2/3. So that gives us this line here. Adding 2/3 to both sides, multiplying by 3 over 2. gives us a being 16 to the 2/3. Now 16 is 2 to the power of 4, so it's 2 to the power of 4 to the power of 2/3. Multiply these powers together and we get 2 to the power of 8/3, so k is 8/3. Question 9. So the hint. Now the key thing here is that the two terms on the left hand side are both log to the base 4. So you really want to get the right hand side also to introduce log to the base 4. Now remember, anything to its own base is 1. So we can just replace the 1 with one lot of log 4 to the base 4. And then we can just basically simplify the left hand side down to one term using the subtraction rule, the division rule, okay? And then, oh yes, and I forgot to say, I've also initially used the power rule. I've taken that 2 upstairs. So that 2's gone upstairs, power rule. And then to simplify it down to a single term, we use the division rule. And then we've got log to the base 4 something equaling log 4 to the base, log to the base 4 something. So these two components here have to equal each other, and then it's just normal algebra to solve that quadratic. Now you're going to get two solutions because it's a quadratic, and you've just got to then think about, are both those values of x valid? One of them might not be. And our solution to question 9. So carrying on from the hint, we've introduced log 4 to the base 4 on the right hand side. Remember, log anything to its own base is 1. So now all three terms have got a log to the base 4 in them. We've then tidied up the left hand side. We've taken the 2 upstairs using the power rule and then combined it into a single term using the division rule. We've then got log to the base 4 something equaling log to the base 4 something. So these two components equal each other, and then we've just solved that quadratic. So we've multiplied by x plus 5, we've expanded the bracket 2 minus x all squared, and then we've simplified it to being a quadratic equaling 0, and I've then completed the square to get my two solutions of 4 plus or minus 4 root 2. Now, you've then got to consider, are both of these valid? Now, when x is 4 plus 4 root 2, this first term here, the 2 minus 4 plus 4 root 2 would be negative. Okay, now you can't log a negative number, so 4 plus 4 root 2 does not give us a valid solution. So your final answer has to be only 4 minus 4 root 2. Question 10. So here's the hint. I think with any of these coordinate geometry questions, just start off with a sketch to gather your thoughts. So for part A, we're just looking at the bit here in red and green. So I've got the centre 2, 5 and the point P lying on the circle of minus 2, 3. Now your starting point for an equation of a circle is x minus x1 all squared plus y minus y1 all squared equals r squared. And we can just use Pythagoras here to work out what r squared is, okay? Because we can see that our base of the triangle goes from minus 2 to 2, and the height of the triangle goes from 3 to 5. Now for part B, again, I've added the purple bit to my sketch to help me gather my thoughts. So we're going to, so your process here is going to be, step 1, find the gradient of PC. Well, that's easy enough, just y step over x step. The gradient of the tangent then for of the line PQ is going to be easy to find. Just flip it over, change the sign. That will allow us to work out the equation of the line PQ using y minus y1 equals mx minus x1. We now know the gradient and we know a point on the line P. And then once you've got the equation of the line PQ, substitute in x being 2 to work out the y value k. So the solution for question 10, following on from the hint. So we know that the radius is obviously going from P to C. The base of the triangle is going from minus 2 to 2, which is a length of 4. and the height of the triangle is going from 3 to 5, which is a height of 2. So using Pythagoras, the radius squared equals 4 squared plus 2 squared, which is 20. So using the equation of a circle, we're substituting in the center, which is 2, 5, and as I just said, the radius squared equals 20. Now for part B, the gradient of PC is y step over x step, which is 2 over 4, which is a half. Therefore, the gradient of the line L is going from P to Q is going to be flip that over, change the sign, which is minus 2. So the equation of line L using y minus y1 equals mx minus x1, substituting in the point minus 2, 3, and a gradient of minus 2 gives us this, which simplified gives me y equals minus 2x minus 1. Now we're trying to work out the coordinates of Q when x equals 2. So substituting in x equals 2, I get the value of k being minus 5. Question 11. So the hints for this, so for part I, just let capital X equal 2 theta plus 10 and adjust your boundaries for theta accordingly. And then work out your primary solution for capital X. So that's when inverse sin equals minus 0.6, and then use the cast diagram to find all the relevant values for capital X, and then convert back to work out all your values for theta. Now for part 2, we've got to find the two errors. So first of all, as we go from the line 3 to line 4, we've divided through by sin x. So think of the implications of dividing through by sin x. Do we lose any solutions? And then secondly, the second error, well, yes, x equals 29 is a valid solution, but are there any other valid solutions to cos x equaling 7 over 8 between minus 90 and plus 90? Now for part B, you'll see that this here is just a variation of our starting point for 2 part A, where x is being replaced by 4 alpha plus 199. So go back to your 2A answers and think about all the various solutions. So both those that you found within this restriction of minus 90 and plus 90, but then just think about other possible solutions if you ignore this restriction. And then which of those are going to be such that it gives you a small positive value for alpha. So of your various solutions for x, which ones that give us a small, well, which one gives us a small positive solution for alpha? And the solutions for question 11. So just really following the process for part I, let capital X equals 2 theta plus 10, and then doubling each of these restrictions and adding 10, it gives us my revised boundaries of minus 170 and 550. So now working with my capital X, sin x equals minus 0.6, so I can get my principal solution from solving inverse sin of minus 0.6. Using my calculator in degrees mode, I get my principal solution of minus 36.87. So using my cast diagram, where I'm getting a negative solution for sin, okay, negative solution for sin within these boundaries here between minus 170 and 550, these are the 4 values I get for capital X. Then converting back to theta by taking away 10 and dividing by 2, I get these 4 solutions for theta. Now for part 2A, think about what happens as I go from line 3 to 4. I'm dividing through by sin x rather than perhaps just rearranging and factorizing. So I'm losing my solutions for when sin x equals 0. Do I get any solutions from sin x being 0? Well, yes, I do, because sin of 0 is 0, and that's within my range. So I'm losing the solution x equals 0. So that's the first error, the loss of a solution by dividing through by sin x. And then secondly, yes, 29.0 is a solution, but I've got to pick up all the solutions between minus 90 and plus 90. So I'm missing the solution using my cast diagram of here of minus 29.0 degrees. So I've lost a solution because I'm trying to find all the solutions when cos is positive between minus 90 and plus 90. Now for part B, obviously the equation I've been given, we've just replaced x with 4 alpha plus 190. So going back to 2 part A, what are my various solutions I get? Well, I get minus 29 and plus 29. And then if I just sort of ignore the restrictions and carry on with what will be my next positive value, well, my next positive value, I'd go around another 360 degrees, giving me 331 degrees. So those are 3 values for x. Now, just substituting each of them in turn into equaling 4 alpha plus 199, I see that what value of alpha would give me minus 29? Well, alpha will be negative. Same for 4 alpha being plus 199 being 29, alpha would again be negative. And my first positive solution for alpha is when I set it equal to 331. That gives me an alpha value of 33.0 degrees. Question 12. So the hints for this question. Now at point A is where the line L intercepts with the curve C. So we just need to solve where the line 8x minus 16 equals the curve 3x minus 2 root x. So rearrange this to make it equal to 0. Then I think the easiest thing to do then is to use the substitution y equals root x. And then once you've found your solutions for y, work out what, convert back to working out what x is. Now for part B, we're going to need to have 3 inequalities, okay, involving the curve, the dotted line and the solid line. Now, but remember that where it's a dotted line, we use either greater than or less than, whereas with the solid complete line is the greater than or equal or less than or equal. Now, the third inequality is going to include this vertical line here, which is where the curve equals 0. Okay, so to find point B, solve 3x minus 2 root x equals 0. So the solutions for question 12. So for part A, we've got to find point A where the curve intercepts the line. So solve 3x minus 2 root x being the curve equals 8x minus 16 being the line. So rearranging this to equaling 0, we get 5x plus 2 root x minus 16 equaling 0. So I think it's easiest then just to replace root x with y. So x is y squared. So solve 5y squared plus 2y minus 16 equals 0. So factorising that, I get 5y minus 8, y plus 2 equals 0. So my 2 solutions for y are 8 root 5 and minus 2. So that is what root x equals. So to work out what x equals, I need to square. Well, I need to. So I've got. Yes. So the root x. What number square rooted gives me minus 2? Well, there isn't a number, so there's no solution for this one. And then my first solution, squaring both sides, I get 64 over 25. Because the square root of that is 8 over 5. So my value, my x coordinate for A is 64 over 25. Now for part B, I need my 3 inequalities. So involving the dotted line, okay, the line L, there are all the values where y is greater than 8x minus 16. I'm below the curve, so that's y being less than or equal to 3x minus 2 root x. And then for the third inequality, I need to work out the point B. Now this is where the curve equals 0. So 3x minus 2 root x equals 0. So 3x equals 2 root x. So x to the power of a half equals 2/3. So yes, I shouldn't have said equals 4/9 here. What I should say is therefore x equals 4/9. Okay, sorry. Obviously 2/3 doesn't equal 4/9. So x to the half equals 2/3. So x equals 4/9 at point B. So the inequality is all the points to the right of that. So that's x being greater than or equal to 4/9. Question 13. So, for part A, state the surface area of the pond covered by the weed at the start of the investigation. So, at the start of the investigation is when t equals 0. So, just substitute t being 0 into the equation to work out what A is. Now, for part B, we're talking about the rate of increase. So, you need to differentiate with respect to t the equation. So, find dA dt. And then we need to work out after exactly 5 days, so then substitute in when t equals 5. Now for part C, given that the pond has a surface area of 100, so the area equals 100, so we need to go and solve 100 equaling 0.2 e to the 0.33 t. And just give you an extra hint there, you are going to have to learn to help you solve that equation. Now for part D, what you want to do here is compare your answer from part C, how many hours it took, or how many days and hours it took, to the statement that by the end of the month 90% of the surface area was covered, and just see how your answer to part C compares to that statement to evaluate the strength of the model. And the solution for question 13. So for part A, when t equals 0, a equals 0.2 e to the power of 0. Well, anything to the power of 0 is 1, so the area is 0.2 meters squared. Now for part B, the rate of increase, we need to differentiate to get the rate of increase. So dA dt equals 0.3 lots of 0.2 e to the 0.3t, which is 0.06 times e to the 0.3t. Now, what is that when number of exactly 5 days? So that's when t is 5. So substituting 5 in, we get 0.269 meters squared per day. Now, for part C, find the nearest hour of the time taken for the surface area to be 100 meters squared. So the area is 100. So 100 equals 0.2 e to the 0.3t. Multiplied by 5. Gives us this. Learn both sides gives us this. Then the power rule, the 0.3t comes down to the front. So we've got 0.3t to the ln e. Well, ln e is 1. So ln 500 equals 0.3t. Divide by 0.3 gives t being this. Now that's it as a decimal, but reading the question, we need it to the nearest hour. Now 0.715 of a day is 17 hours to the nearest hour. So your answer for part C is 20 days, 17 hours. Now we had to go from part D, we're given the fact that after a month, so after 30 or 31 days, 90% of the surface area was covered. Well, our model suggested it would be 100% covered in only 20 days, 17 hours. So that suggests that the model is not accurate. Question 14. So your hint for this. Now we can work out what A and B are by just solving the equation equaling 0. Now because this is already factorized, don't start multiplying out to work out A and B. Just think what values for X would make this equal to 0. So you can quickly establish what A and B is. Obviously A is going to be less than B. Now, for the point of view of working out what C is, you're going to have to differentiate the curve and set it equal to 0 because it's obviously a maximum point. So multiply out your brackets to get y equaling it something, and term by term. Differentiate that, set that to 0 to allow you to work out what C is, and then you're going to need to integrate your curve. And your boundaries will be in C that you've already worked out. Okay, so just so we're clear, A and B you can establish just from this before you multiply out, setting it equal to 0. You're going to have to differentiate to work out C, and then integrate between B and C to work out the area R. And you're going to need to multiply out the brackets before both the differentiating and the integrating stages. So your solutions for question 14. So just looking at the equation for C, we can see it equals 0 when x is 2 and minus 3. Okay, what makes this first component 0 is when x is 2. What makes the second component 0 is when x is minus 3. So our 2 points of interception on the x-axis are minus 3, which isn't relevant to the question, and plus 2, which is, as it's going to be the upper boundary when we integrate. Now we do need to work out the x-coordinate of here, okay, and that's at the maximum point. So we're going to differentiate the curve. So start off by multiplying out the curve. So x minus 2 all squared is x squared minus 4x plus 4. Then multiplying that by x plus 3 and simplifying, we get y being this cubic here. Now differentiating that, I get 3x squared minus 2x minus 8. And then setting that equal to 0 and factorizing, I get x being minus 4 over 3 or 2. Now obviously 2 is the minimum point. The maximum point is C being minus 4 over 3. So I then need to integrate between my boundaries of 2 and minus 4 over 3. So integrating my curve, I get this. Remember, you just add 1 to the power, divide by the new power. So that's it when it's integrated. Substituting in 2, substituting in minus 4 over 3, subtracting 1 from the other, I get the area region being this here.